Hello, this is Ryan Woodward recording for Intel's Digital Logic course. This is Lab 3, Part 2. And in this part, we needed to build a basic D latch. And this is honestly was super simple. You could probably just Google D latch code on the internet and you could come up with something very similar to this. And admittedly, I had already done a D latch in my embedded systems course at Grand Canyon University, but that D latch specifically included an enable input and a reset input, so it wasn't applicable necessarily to this, so I slimmed it down and just used the necessary inputs and outputs described in the lab document. And it's very basic, it's not hard to follow at all. We have a basic behavioral architecture for our inputs D, clock, and our outputs Q and Q bar. And we merely process clock. If clock is 1, Q will be D, and if then it will Q bar will be not D. Basically, Q bar is the inverse of Q, so Q bar will never be the value of Q. And if it is not, then Q is not the value of D. And that's basically it. We don't even have to specify that to get the proper behavior. And honestly, there's not much more to go into because this is a very straightforward and, in my opinion, one of the more simpler latches that we could code. Once we get into more of the flip-flop style, including enables and reset inputs, then it gets a little more complex, and perhaps in a future video I'll actually include that on a different board. I do believe I have a D flip-flop in my YouTube, so you can go check that out if you like. But here is a brief demo of the D latch. Thank you. All right, and this is Lab 3, Part 2, our basic D latch. We have D on the end here, and our clock is just adjacent to that at switch 1. We have Q at LADR 1 and Q bar at LADR 0 here, which is currently high. So the expectation to get Q bar to be high like that, D actually has to be 0. So this is actually correct. But for instance, if we want to flip D high, we should see Q. We should see Q go high. We clock that, and then Q will go high. And if we drop D down and we clock that, Q bar will then return to being high. And that's actually it. There's not much more than that, to be honest. If they're both 0, then basically whatever states they're at remains. So it's kind of irrelevant, even though D could go high, the state will remain, so Q remains Q and Q bar remains Q bar. All right, and that's it. Thank you.